Alright, lesson 2.6 and 2.7 is on families of functions, and the objective is to analyze transformations of functions. Alright, we're going to begin by talking about a parent function. This is the simplest form in a set of functions that form a family. The function y equals x is the parent linear function, and the function y equals x squared is the parent quadratic function. Right, and so here are some basic parent functions: linear, quadratic, cubic, and absolute value, and what they look like. So a linear function is a line. A quadratic is U-shaped, and we call that a parabola. A cubic function looks like a snake, and an absolute value function is V-shaped. Alright, and those that you see there are the parent functions. So it's the most basic form. So what do we mean by most basic form? Well, we have y equals x squared. That's a parent function for the quadratic family. And let's just say I write y equals x squared, 3x squared plus 2. Okay. This isn't the most basic. All right, we have some numbers here. We got a 3 times the x squared, and then we have a plus 2 at the end. And we're going to learn in this lesson what these numbers and where they're located within the function, how they affect the graph of the parent function. And so, how does it transform the graph? And what we mean by that is moves it left, moves it right, moves it up, moves it down, widens it out, shrinks it, and so on and so forth. And so that is the essence of what we're going to be talking about in this lesson today. Alright, so there is that vocabulary word, transformation. And like I just said, it's a change in position, size, or shape of a figure. We're going to talk right now about horizontal translations. All right, it's the number in the parentheses, and what I would do is I would highly suggest using markers or colored pencils to highlight the equation and then its corresponding graph, because yours is in black and white. So what was I just saying? Oh yeah, the number in the parentheses. So there's my sets of parentheses. There's my parentheses. The number in the parentheses right here. So if you're adding to the x inside parentheses or subtracting to the x inside parentheses, what you're going to be doing is shifting the graph right or left. All right, and it's kind of counterintuitive. It's the opposite of what you would think, meaning that this x minus 3. So when we subtract from the x, what's happening is we're moving the graph to the right 3. You would think we'd be moving it to the left 3, but no, we move it to the right 3. Counterintuitive. All right, the blue f of x equaling x plus 3 squared. So here we're adding 3 to the x. The plus 3 is inside the parentheses with the x. So when we add to the x, we're moving left. So we're going to take this parent function right here and move every single point to the left 3. So those are horizontal translations. All right, next are vertical translations. All right, so here we're moving the graph up and down. And so how do you know if you're moving it up or down? Well, you're adding or subtracting a number to the function, and this number is on the outside, so it's not inside the parentheses with the x. Okay, this is on the outside. It's hanging off at the end. All right, so I circled the plus 4 and the minus 4. All right, so you're gonna, in blue here, y equals x squared plus 4. Again, the plus 4 is kind of at the end. It's on the outside. What does that do to the parent function? well, the parent function would be right here, and as you can see, it moves it up. It moves it up 4. And then when we subtract 4, the parent function, we move it down 4 units. And this is a really helpful hint here to remember the difference between horizontal and vertical translations. You want to think add to the x, go left, add to the y, go high. I just moved it back a slide, so add to the x, go left. Alright, so you can see here in our blue that when we add to the x, this graph gets moved left. And then the opposite would be true. If we were to subtract from the x, you'd go to the right. Alright, when we say add to the y, go high, when we say add to the y, that means we're basically adding or subtracting to the function. So it's just think about, hey, is there a number kind of hanging off at the end outside of the parentheses? And then what we mean by that would be, hey, we're adding to the y. Alright, we don't really need to get too much more into the details other than that. So add to the y, go high. So this plus 4, it's hanging off at the end. We're moving the parent function, which would be right here, we're moving it up 4. And then the opposite would be true. If we're subtracting from the y, we're going down. Alright, next up is vertical stretches and compressions. Alright, so this is another type of transformation. And this is the number out front. It multiplies the value to the whole function. Right, so here's our parent, and then in purple, right, we have f of x equaling 3x cubed. So this 3 out in front is an example of a vertical stretch. Right? And how do I know it's a stretch? Because it's greater than 1. And look at what that does. So here is y equals 3x squared. So it basically makes the graph look skinnier. Contrast that to the graph in green. We have here the number out in front is 1/4. Because that number is a fraction, we have a vertical compression. And notice what that does to the graph of the parent function. It makes it look wide. It makes it wider and fatter. Kind of pushes it down. All right. The next type of transformation is a reflection. All right. So here's the parent function, f of x equaling x squared. We can see it in blue here. All right. Now, a reflection across the x-axis occurs when the number out front is negative. Okay. So if you have a negative out in front, a -1, a -3, a -5, it doesn't matter, a -1/4. If there's a negative out in front, all right, what you have to do is reflect the parent function across the x-axis. And so that would be the result. In purple, that's y equals -x squared. All right, reflection now in the y-axis. So the variable x inside parentheses is negative. Okay, so if you have parentheses, like we do right here, and that x is negative inside the parentheses, what you have is a reflection across the y-axis. Okay, so here is, in red, we have x minus 1 squared. And then just by making the x negative inside parentheses, what happens? You reflect across the y-axis. Right, so it's like you're looking into a mirror. You kind of flip it. So this goes over there, this comes over here. And the result is this parabola. Alright, and then here in this slide it sums everything up. Alright, so our h, okay, that number is responsible for the horizontal shift left or right. This number k is responsible for the shift of the graph up or down. This number a is the vertical stretch or the vertical compression. So it's a vertical stretch if our a is greater than 1. If a is a fraction, meaning it's between 0 and 1, it's a vertical compression, so it looks wider. If a is negative, it opens down, or that we have a reflection across the x-axis. And if a is positive, it opens up the graph. Right? So this kind of reviews everything that we just went over. Okay, I know that was a lot, and we are going to make now some sense of this in the examples. All right, it's definitely going to be clear as we work through these example problems what you need to do here. So the first examples, what transformations change the graph of f of x to the graph of g of x? So notice that I've already graphed f of x. All right, that is the quadratic parent function, and the vertex is at the origin there. Okay, now what we need to do is we need to graph g of x and describe what transformations change the graph of f of x to the graph of g of x. All right, so you see here that we're subtracting 5 from the x. So remember the hint, add to the x, go left. Well, we're not adding to the x, so we're not going left. We're subtracting from the x, so we go right. So how far right do we go? We're going right 5 units. Okay? And then add to the x, go left, add to the y, go high. So here we're adding to the y. And so when we do that, when you add to the y, you go high. So we're going to move it up 8 units. Okay? So what we're going to do is we're going to move the vertex of the parabola. All right, so we're going to move it to the right 5, and then we're going to move it up 8. And it's going to be about right there. And then you just draw your U. Okay? For the next one, so here's our parent function. We graphed it already. So now g of x, what transformations change the graph of x to the graph of g of x? So here we're adding to the x. So add to the x, go left. So left 4 units. And then we're subtracting from the y, so we're going to go down 5 units. And so we're going to move the vertex left 4 and then down 5. So there's the new vertex, and then you just draw your U. Let me make that. It's hard for me to see. 1, 2, 3, 4. 4 left, and then 5 down. You get the idea. It's real hard for me to see that. Okay, next. Alright, and the next one here, the function f of x is equal to x squared. So again, we have the parent quadratic function. and it says that the graph of g of x is f of x translated to the left 6 units and down 5 units. What is the function rule for g of x? Alright, so g of x is going to equal. Alright, so we want to move left 6. So remember the hint. Add to the x, go left. So this is going to be x plus 6 and then squared. Okay, remember our horizontal shift left or right, we're adding or subtracting 6 inside the parentheses with x. Alright, so notice the x plus 6 is inside parentheses. Notice where the square is. It's outside of the parentheses. Alright, don't put it inside the parentheses with the x there. That's incorrect. It's outside. And then we go down 5. So add to the x, go left. Add to the y, go high. Well, I don't want to add to the y to make it go up. I want it to go down, so I'm going to subtract 5. And there's your function rule. Alright, for the next one, the graph of g of x is f of x translated to the right 3 units and up 5 units. What's the rule? Okay, so we have g of x equaling. Alright, so we want to go right 3. So add to the x, go left. So if we subtract, we would go right. So we want x minus 3. That's inside the parentheses with the x, and then we put the square outside of it. And then we want to move it up 5. So we add 5 at the end. Let g of x be the reflection of f of x equaling x squared plus 3 in the x-axis. What's the function rule for g of x? Alright, so remember for reflections that the number out front is negative. Alright, so we want to have a negative out in front. So what we're going to have to do is multiply the entire function by a negative. Okay, so and then distribute. So our g of x is going to equal negative x squared minus 3. Alright, so you see that? So a reflection in the about the x-axis, you multiply the entire function by a negative 1. Alright, and then the last one, look at the previous problem. What is the function rule for a reflection across the y-axis? Alright, so here all you're doing is plugging in a negative x. So you're just multiplying the x by negative 1. So not the entire function, just the x. Or in other words, substitute negative x in for x here. So I'm going to have negative x squared plus 3. Alright, so however you want to think about that, think about just multiply the x by negative 1. Right, so nothing happens to the positive 3. Alright, next examples, we want to graph this. So we want to graph f of x equaling x minus 2 squared plus 3. So here's the parent function, y equals x. Alright, and it's just a sketch, and really all I'm concerned about is where's the vertex and what is the shape. So the vertex is at the origin, 0, 0, and its shape is, it looks like a U. Alright, so this right here, add to the x, go left. So if we subtract from the x, like we're doing here, we're subtracting 2, we go right. So right 2. And then we add to the y, we're going high. So up 3. So here's my vertex right here at the origin. I'm going to move it right 2 and up 3. So this is going to be the new spot. And then draw your U. Okay, now for this next one, we're not dealing with the quadratic equation, a quadratic equation anymore. This is an absolute value equation. So what does the parent absolute value function look like? It's V-shaped, where its vertex is at the origin. Okay, so now we're going to move this. Add to the x. So it's not inside parentheses, it's inside the absolute value bars. Think about it in the same way. So add to the x, go left. So we're left 5. And then add to the y, go high, up 2. So we're going to move the vertex 5 left and up 2. So there's the new vertex, and then just draw your V. Alright, and then for the last one here, we're back with quadratics. So y equals x squared is the parent quadratic. So that looks something like that. So let's graph this. X squared minus 9. Alright, so we're not adding or subtracting anything to the x. The x is not inside parentheses with a number. So we have no horizontal shift left or right. This minus 9, so we're subtracting 9, that's outside, hanging off at the end. That means we're going to move everything down 9. So the new vertex is going to be here. And I don't want it to look that much fatter. Okay. So there's x squared minus 9. Now, in part B, we have to graph negative x squared plus 9. So if I have x squared minus 9, and I multiply this whole function by a negative 1, what do I get? I get negative x squared plus 9, which I need to graph. Well, since I multiplied this entire function by a negative 1, I am reflecting across the x-axis. So this is a reflection across the x-axis. So I'm going to take this point and I'm going to move it, I'm going to reflect it across the x, so now it's over here. And then instead of opening up, a reflection across the x is going to make this open down. And there's your graph. Alright, so it was a pretty long video. Thanks for sticking with it. This is only going to get easier the more practice that you get. I know that was a lot, but like I said, the more practice we're going to do in class, the better you're going to get with this.